So why exactly would it be 30, 86, 85, and 87? Why would relays be numbered in that way? Well, the answer is actually quite simple, and that is Bosch. Well, Bosch has been making vehicle electronics for a long time. Now, during the Industrial Revolution in Germany, a lot of engineers came together and they formed a group called the DIN, which is the German Standards Institute. Now, they made standards for many or a lot of industries, and one of those industries include vehicle electronics. And in the standards for vehicle electronics, there was also included schematics for vehicle components. And in these schematics for vehicle components, there were pin numbers for all the different components and pins. When they got round to relays, it was 30, 85, 86, and 87. And that just stayed that way up until today. So thank you very much, German engineering. And that is why almost all of these, or most of these relays are called DIN relays or Bosch relays, because that is where the standard comes from. So how does it work exactly on a relay like this? 30 at the bottom, 86 on the left side, 87 on top, and 85 on the right hand side, like this. What are the purposes of these? Well, on the inside of the relay, there is a coil, which is represented by this symbol over here. And between 85 and 86, if you supply 12 volts, and in this relay's case, because this is a 12-volt relay, this magnet will be engaged of the solenoid, and it will complete a circuit between 30 and 87 on the outside, like that. It will basically close a contact point. So let's have a look how that works. I've got another relay which is opened. The norm on these relays, on almost all of them, is that 85 is the ground or the earth. Now, on this specific relay, the points look a bit different, but we're going to see how it works anyway. You'll see that there's this little plate on the side here. And in the middle of those two plates, there is a contact point. So if I supply 12 volt over those 2 points, which is 85 and 86, you'll see that the plate there moves. So basically the coil gives a magnetic field and it attracts that contact point, making contact between those 2 plates. Then basically once that is engaged, what it does, it makes contact between where this would then be 85 and 86 that was engaged, or that engaged the electromagnet, and that completes the circuit between 30 at the bottom and 87 on top. So that is basically just a switch. And a normal relays is a 4-pin relay like this, which works like I just showed you. And then you get another one with a 5th pin, which is right in the middle there usually. Now this one doesn't have it, but the reason for the 5th pin would be quite interesting. The 5th pin would be called 87A. It would have a A next to the 87. And the reason for that would be, if we use this one for example again, in the case of this relay, the outer pin over there would be 87A and the inner pin would be 87. So in other words, if the relay is not in use, in other words, there is no electricity or 12 volt connected to the point, then it would not be engaged. But while it is not engaged, you'll see that the contact is still closed on the outside, so it is making contact with 87A. So between 30, if we can get this one again, between 30 at the bottom and 87A, there would be contact and would be a complete circuit. And then once again, when we engage 12 volts to the coil's other side, if you can bring it a bit closer, you'll see it then engages to a different point like that. And then it disengages from the first one. So it disengages from 87A and engages to 87. Let me put this one down. And that is pretty straightforward. So if it had an 87A pin in the middle, right over there, in a normally open state or a disengaged state of the coil, there would be a current or connection between 30 and 87A. But as soon as you apply voltage over the coil's 2 points, the current or the connection changes from 30 to 87 and then disengages the middle one. And that is basically it. I will put a schematic on the screen as well so you can see the difference between a 4-pin and a 5-pin one. Now, also, between the 4-pin and the 4-pin relays, there are two different side ones or different style ones. They look exactly the same if you look at them like that, but the numbers are different. You get a type A relay and a type B relay. What I've got in my hand here is a type A relay. Now, the most common one that we use is a type B relay, which I showed you is normally 30 at the bottom, 87 on top, 86 on the left, and 85 on the right. That is the most common one. That is the type B one. But the type A one that I've got in my hand here has got the 30 on the left, the 86 on the bottom, and then the other two are still the same, 87 on top, like you can see over there, and 85 on the right. So in other words, they have basically swapped these two terminals, 30 and 86. So that is for a different application. Although the pins are in exactly the same place, the allocation of the pins or the purpose of the pins are different. So whenever you're changing one of these 4-pin relays, it is very important that you double check which one you do have. Is it a type A or a type B? Because obviously 30 is normally directly 12-volt power from your battery or your power source, and that normally goes to 87 once the coil is engaged between 85 and 86. So obviously, if these two are swapped and you put the wrong relay in your vehicle, you can cause severe damage to your electronics or computer systems. So very important that you check which one you need. I'm going to put a schematic on the screen as well so you can just possibly or properly see while these two terminals are swapped. Now, coming back to checking which ones you do have. Now, you do get quite a couple of relays, and they all do pretty much the same thing, but they've got different terminals, different terminal points, and that can be a bit confusing and can cause problems if done incorrectly. So that's the normal 4-pin one. I did explain the 5-pin one as well. Now, the other one that I've opened is a VW Audi Group relay, and that is also with the terminals in completely different places. You'll also see that two of the terminals are quite smaller than two of the other ones. Now, the two bigger terminals is usually 30 and 87, and those are the terminals that carries the bigger current loads, while the smaller two are only the pins that engages the coil and it requires a small amount or smaller current. And once again, this is 30 at the bottom, one of the bigger terminals, and 87 on top. And then 85 and 86 are the two smaller ones that engage the terminal. But they completely rearranged the terminals in a different manner. So we'll put that one on there as well. Put it on the side like so. Now next, we've got another one which looks normal, but it doesn't have any numbering or schematic on the casing, or at the bottom it doesn't have any numbers either. So in this case, this is a normal B-type 4-pin relay. Once again, it's got two big terminals and two smaller terminals, and the normal ones is 30 at the bottom, 87 on top, on the left 86, and on the right 85. And once again, 85 is normally grounded, and 86 receives the signal power from whatever source you've got to engage the relay. And then at the bottom, 30 is usually your main power source from either your battery, which is a fused line normally, and that it then is connected to 87 on top once the solenoid is engaged over the other two terminals. So once, or if there are no schematics on the relay, that is normally what the schematics or the pinouts are. Let's put this one down there as well. And then you get this Mercedes relay, which does have numbers on the pins, but once again, the pins are completely rearranged. They are in different places. So once again, very important to read the numbers on the pins to see which ones are meant for what purpose. Another nice feature of this relay is it's got a built-in fuse. So it's got a fuse between the main points, which is not between 30 and 87. So between 30 and the contact point, it's got a built-in fuse of 30 amps, since this is a 30 amp relay. So should something go wrong inside your relay or on your wiring, it'll just simply blow this fuse and you can easily replace it without any difficulty. Let's put that one there as well. And then we come to a normal one, another 4-point relay without any schematics, but it's got 4 pins at the bottom, all linear like that. Once again, for a specific reason only. So once again, very important to be sure that you know which relay you've got and which one you need to replace this with. So if this helped you whatsoever, please be sure to like this video. Also subscribe to my channel if you haven't yet. So if you want to support my channel, please have a look at the super thanks icon down below. So until next time, thank you very much, guys.